So it's my honor and pleasure to turn it over to our briefing facilitator and someone, frankly, that needs no introduction, but we are certainly very, very glad that he is here, and NASA headquarters has welcomed him back to take the helm, the Associate Administrator for the Science Mission Directorate, Dr. Ed Weiler.
Good morning, everybody. The first thing I'm going to do is introduce my panel, and then I'm going to give a brief overview of the mission. On my far right is Mr. Doug McQuistion. He's the director of the NASA headquarters Mars Exploration Program. He'll be giving us a program overview in a short while. To my immediate right is Dr. Peter Smith. He is the Phoenix Principal Investigator. He's from the University of Arizona, Tucson, and Peter will be telling us about what science he plans to do on the surface of Mars. To my immediate left is Dr. Ray Arvidsson. He's the Landing Site Working Group Chairman. He's from the Washington University in St. Louis. And then on my far right is Mr. Barry Goldstein. He's the Phoenix Project Manager at the Jet Propulsion Laboratory in Pasadena. And he'll be telling us about the landing process and especially the challenges involved. So I'm going to spend my time a little bit on brief history before my colleagues get into the details. Seldom in a 30-year career at NASA like mine do you cancel a spacecraft in 1 year and then reselect it several years later and then get to talk about it just a few weeks before it attempts to land on Mars. Phoenix is truly an appropriate name for this mission, as it has risen from the ashes of 2 Mars failures back in 1999. In '99, an identical lander named the Mars Polar Lander crashed on the south polar cap of Mars. This was the second Mars failure in a row in the Mars program of the late 1990s, the faster, better, cheaper era. With both, we had achieved the faster and the cheaper aspects of that goal. But the better was clearly missing, as all we accomplished was 2 craters on Mars. But that is the negative side of the story. In 2000, I canceled all remaining missions in that failed Mars architecture except the 2001 orbiter, later named Odyssey. The canceled missions were the 2001 lander, an identical twin to the MPL, a sample return mission, set of missions to be launched in 2003 and 2005. We then restructured the Mars program to attempt a mission launch every 26 months and focus the science to follow the water. One of the major goals of the current Mars program is to answer the question of whether life now or ever existed on Mars, and we know that without water, there is no life. We also attempted to lay out a program and budget that tried to do a better job of equally balancing the goals of faster, better, and cheaper. The rest is history, as we've had 4 successes in a row: Mars Odyssey, the 2 Mars rovers, and the Mars Reconnaissance Orbiter. And that brings us to Phoenix. We selected this mission through an open competition and peer review in the early part of this decade. Dr. Peter Smith, University of Arizona, proposed to take the canceled spacecraft from the 2001 lander and fix its known problems and launch it to the North Polar regions of Mars. The team has done everything possible to ensure a successful landing in a few weeks. But remember, although we fixed all the known issues from the Mars Polar Lander, there are always the unknown unknowns. And of course, there's Mars itself. 55% of all human attempts to land robots on Mars have failed. The U.S. has a better record, as we have succeeded in 5 of 6 attempts. But 3 of those 5 successes employed airbags. Viking was the last time we successfully used retropropulsion and landing legs. So it has been over 32 years since NASA has been successful in such a landing. And even then, Viking dropped its 2 landers from an orbiting spacecraft, whereas Phoenix is coming in from deep space at a much higher entry velocity. So I hope that I've convinced you that this is no trip to Grandma's for the weekend. There are many, many risks and uncertainties. But as someone once said a long time ago about NASA, we do these things not because they are easy, but because they are hard. And the scientific payoff will be well worth the risk, as you're about to hear from my colleagues. So, Doug, would you like to start off?
I would. Thanks, Ed. Well, it may not be the trip to Grandma's house, but I think we might be using Grandma's car. This is 60s, 70s technology, and these guys, this team, has done an outstanding job in working through this system to make sure we knew as much as we could know about it. So I'd like to first give credit to the team, which would be University of Arizona.